Hello everyone, I'm Snigdha Kakkad and this is my channel Accelerate AI Careers. Today I have brought a very interesting LeetCode problem, LeetCode 1209, remove all adjacent duplicates in string 2. It has been asked by several companies in last 0 to 3 months of their interviews. Some of those companies are Amazon, Bloomberg, Meta, TikTok, Microsoft, Oracle. So it's a pretty important question. Now, why does this question have that significance and what does this question say? You have been given a string s and an integer k. For example, here in example 2, you have been given a string s and k equal to 3 here. So now you have to remove all the adjacent duplicates as the name of the question indicates until no longer you can do that. So basically you have to remove duplicates every time a character occurs k times together, and you have to do it iteratively again and again until you cannot do it anymore. In example 2, you have D, E, 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 D, B, B, C, 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 B, D, A, A, and K is equal to 3 here. So first of all, your first hunch to solve this question or brute force approach to solve this question would be, like, I will go through this example, I will go through this question, and as soon as I come across a character occurring this K times, that is 3 times here, I will get rid of it, I will remove it. So let's do that. So I first have D, and then I have E, so E occurs 3 times, so I can just remove it. Then I will have D, B, B, and then I have C, 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 again occurring 3 times, so I can remove it. And then I have B, D, A, A. So essentially I have iterated through the entire string once. So my time complexity essentially is O of n until now. But you would say that the question is over, but the question is not over here, because the resulting string which you have again has 3 times B occurring here. So you have to get rid of that B here. So you have K times B repeating here adjacent. So you have to first remove that. So I'll do that. And now I have D, 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 A, A. So now again, the question is not done yet. I have 3 times D, or that is K times D occurring here. So I have to get rid of it. So I will have AA. And this AA is my result. Finally, you have to return the string with no more K adjacent duplicates there. And there is a guaranteed answer, and that answer is guaranteed unique here, as mentioned in the question. So now your brute force approach essentially is not O of n time complexity, but you are iterating through the string again and again, and in the worst case scenario, you might be iterating through the string n times. So your time complexity is O of n square. Can we do better in this question rather than solving it this way? Do you have an approach in mind which you can use here? The brute force approach is O of n square time complexity, but can I make better use of certain other approach or certain other data structure that can help me solve this question in O of n time complexity? So pause this video, think about it, and then come back. Okay, so let me share my approach here to solve this question. What I will do, instead of solving it by going through the string again and again, let me show you what approach I thought and how did it come to my mind. So I started with I equal to 0 pointer. As soon as I come across a D, I save my character D and its count as well. So my D has occurred adjacent only once. So my character D has count 1. Now I go ahead and I come across character E. So now I check my previous character. My previous character was D, which is different from E. So my D stored as 1 count, then my E gets stored as 1 count, and then I move ahead. So I go and to the next character, I look at it and it's E, which is equal to the prior character. So I will increment my E's count. Now I come across the next character E. So again, it's equal to the prior character, so I can add the count to this. So now as soon as my count for any character coming up adjacent comes to K, where K here is 3, as soon as it comes to that value, I can pop it. So if I can pop it from the statements I'm saying push or pop, do you understand which data structure I'm referring to? So it's stack. And essentially in my stack, I'll not just store the characters, but I'll store character and count pairs. And I'll keep on updating the count. I'm going through the same character adjacent. So that's what I'm doing here. So let me write it again for you. So I will take a stack with pairs of character and count, and I'll keep on updating it. So as soon as my first character was D, I added the pair D, 1 here in the stack. And as soon as my next character came, which was E, my E's count reached in 3. So essentially this is my stack's top value, top character with its count. As soon as this value reaches k, I can pop it up. And so I popped it and removed this entire pair here. Now you would say I have to start from the beginning again, but that's not true. I need not start from the beginning. I just need the topmost character and count in the stack to see which character was occurring earlier before I popped the e's. So I come across next character, which is D here. So I will look at my stack's topmost character, which was also a D. So I know I was going through D only before I came across 3 E's. So I can increment the count of D here to 2. Now I come across a B. So I will add B here. And first I increment the count to 1. And then I see another B. So the count becomes 2. Now I come across a C, and my C's first count is 1, then 2, then 3. So I have 3 C's together. As soon as I have count equal to K here, I know that there was a character that occurred K times adjacent. So I can pop it up, and that would be on top of stack. So it will take only O of 1 time complexity to pop it. To push a character to stack is also O of 1. To pop a character is also O of 1. So essentially I'm doing it in minimal time here. Now I come across next character, which is B. So I'll first take the topmost character in stack right now, which is B. And I have B next character. So I'll increment the count here, 3. As soon as this character's count reaches K equal to 3, I can pop it up, and that's what I'm going to do here. So now also I don't have to start from beginning again. I know the stack's topmost character is D now and count is 2. And my next character is also D. So as soon as my count becomes 3 here, so I can pop it up. So it becomes empty here. And now my next character is A and its count becomes 2. So this is my final answer, but I don't need to return the answer in the form of stack. I have to return it in the form of string. So my answer would be AA. That's how we're going to solve this question. We are going to use a stack here. So your space complexity would be O of n, and your time complexity here would be O of n again, because you're going through the entire string and updating the stack, and the push and pop time complexity is O of 1. So essentially you are running through the string, so O of n time complexity. I hope the approach of using the stack with character count pairs is clear to you, and also the reasoning behind not starting from the beginning of the string again and again is also clear, because you only need to see the prior character. You need to look backward and just see the prior character before you pop the adjacent duplicates. And that's it. You don't need to check for counts again from the first character. So if the approach is clear, let's try this approach on our next example. Example 2 here. I will first initialize an empty stack, and my first character is C here. So my count gets updated to 1. Now I come across next character, which is A, which is not equal to prior character on top of the stack. So I'll add A1 here. Now my next character is again, so I will update the count for A. Now my next character is B, so I will add B here, and my count for B changes from 1 and then 2 and then 3. As soon as it reaches 3, and I assume K equal to 3 here, then I can pop it up, and as soon as I pop it out, I have next character as A. So I have to check the character on top of stack which was occurring earlier, which was also A. So I will increment its count. As soon as it reaches 3, that is the K value, I can pop it up. And now my next character is C, and again next character is C. So I have 2 C's to be added. And my character on top of the stack is also C. So I will add 2 here, so C3. Again my K is 3 and C's count also reached 3, so I can pop it up. So essentially my result would be an empty string. So I hope the examples are clear to you as well as the approach. Now let's start coding it. So to code it, first of all, I will initialize my stack, and my stack would essentially be a stack of character and count pairs, like as I showed in the example. After that, I will loop through the entire string for character in string, and then I will check if the stack exists, it's not empty. And the last element of stack, so in Python, the last element of stack is checked by stack -1. So when you check the stack -1, that is the top of the stack value, it would be a character and count pair. And you want to check the character. So the character would be at 0 point indices, and you will check if it is equal to the current character C occurring. If it is, I will increment the count stack -1, so that gets you the topmost character and count value pair in the stack. and then you take its count is at the first indices, and you increment it by 1. Now say suppose if that's not true, either your stack is empty or that character is not the prior character which was occurring. In that case, you will append the current occurring character C to the stack along with its default count 1. So that's how we're gonna go through the entire string and update the counts of character in character count pair. And now I will also check if my stack's top value, which is stack minus 1 in Python, and its count is equal to k. So if it is equal to k, I have to pop it up. So stack dot pop. And now you have the entire result. So, but the result is in the form of stack. So I have to bring it in the form of string. So I will initialize an empty string first, and then I will loop through the character count pairs remaining in the stack. And when I loop through it, I will append it to my string. So in Python, it's very easy to do that. So I will add it to the result, since result is an empty string. And what will I add? I will add character multiplied by count. So say suppose C multiplied by count 2. So 2 times C will be your result. In Python, it's quite easier. And then I can just return my result. So let's run it and see if we made any mistake. It's accepted. Let's submit. So as you can see, our solution is doing quite well here. If you have a better approach to solve this question, let me know in the comments. Any doubts, ask them in the comments. I'll be happy to address it. If you like my way of solving this question, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.